Hey there, my name is Spencer and I hate my 3D printer. I don't actually hate it, but it seems like no matter how much I calibrate it, how dry my filament is, or where the constellations are in the sky, I just can't get a decent quality print anymore. Now, the print in question is my AnyCubic Vyper. It's got an all-metal hot end, it's got automatic bed leveling, a heated bed, and many other great features for a budget 3D printer. Now, it's already been modded with HeroMe Gen7 part cooling. I've installed Clipper as the firmware on the printer, and I changed out the Bowden tubing for Capricorn tubing. Now, while Clipper pushed my printer to its absolute limits, I'm still not pleased with what it's capable of. While the quality of the printer was lacking, I wasn't anywhere near ready to start upgrading the printer and putting money into it. But once my y-axis started skipping steps, I decided it was time to pull the trigger. Adjusting the belt tension, fixing the V-slot wheels, whatever I did, it didn't seem like the printer would stop skipping steps. And this came out of nowhere. Now, my suspicion is that the TMC2209 drivers on the Vyper are overheating or the motherboard is going bad, something along those lines. I believe this because the y-axis motor was too hot to touch during not a very long print session. Along with the missteps, I live in an apartment and I share a room with my printer, and that can be really inconvenient at times, so I really wanted to make the printer as quiet as possible. So at first I just started looking for a new motherboard as a starting point, but that quickly avalanched into just finding tons of parts that I wanted to add to the Vyper. Now, while I am planning on upgrading features of the entire printer, today's video is only going to focus on the print head itself. So what are these upgrades I keep mentioning? Well, first up is the Mosquito hot end from Slice Engineering. This beautiful piece of engineering can print at temperatures as high as 500 degrees Celsius. It can do cold nozzle changes, and it effectively eliminates heat creep. Now, while I was at it, I also grabbed a 0.4mm and a 0.6mm of their new Gamma Master nozzle. This setup should allow me to print much more exotic filaments than just PLA and PETG, like carbon fiber nylon or ASA. Goodbye to the E3D V6 clone that I currently have and all those cheap brass Amazon nozzles I've been stocking up. So for the extruder, I decided to leave behind the Bowden setup and I opted to go for direct drive instead. Now, I was recently watching a video by Stefan over at CNC Kitchen, and he rated the Orbiter by Dr. Robert Lorenz as the all-around best extruder. While I was at it, I grabbed the Orbiter filament sensor. It's a great little runout sensor that comes with some awesome features and fits directly onto the Orbiter 2.0. Now, while the Vyper has automatic bed leveling, it uses its nozzle as a probe and combines that with a strain gauge. The issues I have with this are that to use a strain gauge, the hot end needs to be able to move the slightest bit, and that leads to some inconsistencies in the printer when it moves and changes direction. Also, the nozzle can often have molten plastic on the tip, which leads to a Z offset when the nozzle is probing on the bed, and that leads to bed leveling inaccuracies. So to get away from this, I'm upgrading to the BLTouch from Antclabs. This will hopefully fix all of those problems. Now, I mentioned that I already upgraded to the HeroMe Gen7 part cooling system, and I already have two 5015 radial part cooling fans. But the issue with these, I now realize, is that they are hydraulic bearing fans, and anytime the print head accelerates or moves side to side, it leads to this very, very annoying clicking sound, which I can't stand anymore. So I'm still going with the dual 5015 radial fans, but I've upgraded to brushless dual ball bearing fans instead. Now the hot end fan is being upgraded to a Noctua fan. The Mosquito's heat break is so effective that you don't need as much airflow to get the same amount of cooling that you would need on, say, my V6 clone. So I should be able to run the Noctua at lower speeds, which at those speeds they run virtually quiet. So how am I going to add all of these great parts to my stock printer? That's always a challenge when upgrading your printer, is how do I make it work? Mechanically, I'm upgrading from the HeroMe Gen5 suite to the Gen7 suite. Electrically, I decided to go with the EBB42 from BigTreeTech. Effectively, this lets me plug everything into this little daughter board that goes onto the print head, and that print head uses a really cool thing called CAN communication, controller area network communication. For the purposes of this video, it just means that 4 wires is all you need to connect the print head to the rest of the printer. The current wire loom that has 16-ish wires, 20 wires, gone. So I'm not throwing money at my printer to make it dance. I would like to know if these upgrades are actually worthwhile and improve print quality and my overall experience. To help me make this decision, I decided to do a few test prints in both PLA and PETG to compare the print quality before and after the upgrade. So, to get started, let's load up some PLA into the printer, calibrate it, and then get started on those first test prints. I calibrated my printer using a guide from ls3dp.com. If you've not heard of it, go check it out. He's big into the Voron community and has made a great guide on calibrating your printer. Highly recommend you check it out. Also, I dried all of my filament, whether it was straight new out of the box or not, in my hot box for 6 hours, and then it was stored in a vacuum sealed bag with some desiccant to keep it dry. Starting off with PLA, we're going to be printing the calibration cube, the infamous 3D Benchy, and a model of the Eiffel Tower. This model of the Eiffel Tower was designed not for FDM printing, but for resin printing. Effectively, it's going to be a torture test for the printer. I'll be surprised if it successfully prints before the upgrade and after the upgrade. So for PETG, I'm opting to only print the calibration cube and the 3D Benchy. I thought the Eiffel Tower would be too much with PETG just stringing everywhere. So let's get to printing. The calibration cube came out pretty well. There's a lot of ghosting on both the X and Y axis. Tiny bit of part cooling issue. I don't think I have it dialed in quite as well as it should be. There's also some inconsistency between the layers, but overall, very sharp print, turned out okay. Now, the Benchy also came out fine. The only real big problem is under extrusion, which is a problem that has plagued me. No matter how many times I change the nozzle, do cold pulls, whatever, I always seem to have under extrusion. You can see some gapping along the layers and some inconsistent layer heights. Overall, though, it's okay. Yeah, it's okay. Last but not least was the Eiffel Tower. Now, incredibly, the Vyper actually managed to pull it off. Kind of. Actually, the connection here was so weak that right when I pulled it off of the printer, it broke in two. But pretty incredible. It handled a lot of things like these side fences on the Eiffel Tower, and it even got these very thin bits on the last few layers of the Eiffel Tower at the very top. Overall, incredibly surprised that it worked at all. Now, the reason I'm plagued with under extrusion, as I showed on the Benchy, is because of our next material, PETG. Now, I actually can't find the calibration cube, but I've got a time lapse of it being printed, so I swear I did it. But yeah, if we take a look at the Benchy, you can see the incredible amounts of stringing and branching and all of that. PETG and I and the Vyper together, we don't get along very well, and that's the reason I've got such bad under extrusion, is trying to tame this. Overall, I have the print completed. The details are okay. You can see the seams everywhere. But yeah, beyond retraction issues, printed okay. So now that we have a baseline of what the Vyper is capable of, it's time to get into the upgrades. Now, the first step was to go ahead and print out all of the parts for the HeroMe Gen7 suite, and then add in heat inserts wherever I needed to. So next up was to add the boron nitride paste to add in the 50-watt heater and a PT1000 temperature sensor. Now that the Mosquito has its heater cartridge and thermistor, it was time to mount it to its HeroMe part. But first, we actually needed to cut a small piece of Capricorn tubing that guides the filament from the Orbiter extruder to the Mosquito through the HeroMe part. So to do that, I took some of the spare Capricorn tubing I had and fit it through the parts and marked where I thought it needed to be cut. I then took that and cut it, and while trying to fit it through the parts, I noticed that some of the parts didn't have a wide enough hole for the Capricorn tubing to go in, so I had to take out my drill and drill some of the parts. Now, all these parts were printed with something called PCTG. It's a filament very similar to PETG, but the E's changed to a C, whatever that means in the world of chemistry. And it actually was machined very easily. Had a really good experience with it and would love to make a video on that in the future. Now, after I got the Capricorn tubing cut, I mounted the Mosquito to the extruder mount, mounted that to the universal base of the HeroMe Gen7 system, and on top of that added the Orbiter's mount and the orbiter itself. Next up, I attached the gantry adapters to the side of the universal base. This is what connects the base of the HeroMe to the Vyper's gantry plate. The BLTouch adapter screws on with the left side of the gantry mount as well, so went ahead and added that on. Next up was the part cooling ducts. Now, after adding the new part cooling fans, I went ahead and added the Noctua fan and a fan guard. I'm not sure if I'll keep that in the future, as it adds the most minute bit of weight, but for now it protects me from breaking the fan or my finger. So now that our new print head is pretty much completely assembled, I need to make sure that it's going to fit on the Vyper. So we're going to have to go ahead and remove the current print head from the Vyper. First up, we remove the HeroMe 5, followed by the V6 hot end. After removing that, we can remove some of the strain gauge parts and the daughter board and some other miscellaneous plastic pieces. So I mounted the print head, moved it around, made sure everything fit. I was pretty pleased with how it went, so the next step was to figure out where to put the EBB42, the new daughter board that everything is going to connect to. After realizing that the board wasn't going to be able to just mount to the gantry plate and have everything wired up without there being any clearance issues, I decided that I would mount it to the back of the HeroMe base. Luckily, it had some threaded inserts that I'd put in there for whatever reason. Luckily, it was the exact same spacing as the EBB42 board. So mounted it with 2 screws and it worked great. Now, since the back of the EBB42 wasn't completely flush, I did end up adding some spacers. The biggest problem now is clearance between the wiring and the Vyper gantry plate. In the future, I would like to design and print out some spacers to take the current print head and just space it out a bit from the gantry plate. But for now, I just have these round spacers that screws can go through. So I put one at all 4 screw mounts of the gantry plate, and it brought the print head out enough that I thought everything was going to work. So now that we figured out the mounting and the spacing issues, it was time to get everything wired up. First up was the filament runout sensor, the orbiter sensor. Now the issue with that is that the EBB42 only has 5-volt voltage supplies, and the filament runout sensor recommends a 3-volt supply if the GPIO pins, or the signal pins, are also 3-volt. Now it's okay if you have a 5-volt supply and 5-volt signaling pins, but the EBB doesn't, so I had to find a way to get a 3.3 volt source. I did this using a simple voltage divider. I won't go too in depth to what that is, but basically it gives me a 3.3 volt source utilizing 2 resistors. So after some soldering and some crimping, we managed to get the connector attached to the orbiter filament sensor and get that attached to the EBB board. Next up was the wiring for the orbiter sensor. Pretty much already done, except the wiring from the orbiter to the end of the connector was so long, because typically printers don't use CAN, so they need those very long wires, but we're able to eliminate that. So all I had to do was cut the cable at 2 points and then resolder it together. After that, we wired up the dual part cooling fans. Now there are only 2 fan slots on the EBB board itself, so I was going to use one for the hot end fan, and then I was going to wire up the part cooling fans in parallel and run them off of one connector. This definitely doesn't overdo the amp rating of the board itself, so it was going to be completely fine. Next up was to wire the hot end fan up. Just like for the extruder, the wiring that came with the PT1000 and the heater cartridge were both way too long. I decided to cut those down. For the PT1000, I had to add a connector, so I did some crimping and did that. For the heater cartridge, there are actually 2 terminals on the EBB board, and those are just secured by screwing in the end of the wire. Before I forgot, I went ahead and added the heatsink to the TMC2209. So now that everything is wired up, we can go ahead and attach the print head to the Vyper gantry plate and see if there are any clearance issues. Now, because of the magic of editing, you didn't see the hours I had to spend figuring out those clearance issues. Looking back, I feel really dumb about it, but those spacer eyes I added to the gantry plate earlier ended up being what solved the problem. Now, next up was to create the wire loom for the CAN wiring. So CAN wiring, it's just 4 wires. There's a power wire, a ground wire, a communication high wire, and a communication low wire. Now, these high and low wires, they need to be twisted together to help reduce noise. I decided to go ahead and twist the black and red wire as well, just because, and then I twisted the 2 resulting looms together as well, up to a point. And this was more for looks and convenience, and just having things not fly around for now, but it's only necessary to wind the high and the low communication wires together. So I cut 3 feet length of each wire for the CAN communication. Luckily, it ended up being just long enough, but in the future, I'm going to increase that to 4 feet or more, because it is a bit of a tight squeeze towards the end. Now, the Vyper motherboard doesn't have CAN communication built into it, so how are we going to take care of that? So from BigTreeTech again, I got the IO2 CAN. This is basically a board that just mounts directly to a Pi. You plug the high and low communication wires into that, and it allows the Pi to use CAN communication. So you need to run Clipper to use this, but then basically the Pi is the one doing the CAN communication, not the motherboard. So now that we have the CAN communication wires hooked up, we needed to worry about the power and ground wire. So I had to open up the bottom of the Vyper, which is where the power supply is found. Under there, I found a spare +24 and ground terminal on the power supply. So I had to crimp some little connectors to the end of the power and ground wire, and then just screwed those into the power supply, and boom, we had power. Now this means that the EBB42 power will be at 24 volts. And for the most part, I had accounted for this, but there was one issue I came up with, which I had overlooked for a dumb reason, but we'll get to that. So I powered up the Vyper and no fire, no explosion. It blew my mind. So now that I was confident that no fires were gonna start, I decided it was time to flash the EBB42 board. Now you actually have to flash the board with a version of Clipper. I first tried to use BigTreeTech's way of flashing the board, and it uses the STM32 Cube programmer. It's a piece of software. I think it does work. It ended up that the cable I was using, my computer didn't like it. It was an Anchor cable. It does power and data, so I'm not sure why it didn't like it. So I ended up plugging a USB to USB-C cable in. It was my mouse charger, which was amazing that it actually transfers information. But that ended up working. But by that time, I had moved on to using something called CanBoot. I highly recommend CanBoot. CanBoot is made by not BigTreeTech. I'll have who it is linked in the description. But basically, CanBoot is kind of a version of that Clipper software that goes on the EBB42. And it actually allows you to update that firmware using CAN communication through whatever you use, whether it's Mainsail or Fluid or Octoprint. It'll show up in the update manager. Now, if you go the BigTreeTech way, there is no bootloader. You won't be able to update it automatically like that. You'll have to re-flash it using the same, plugging it in and hitting the buttons, which I did not want to deal with. So I highly recommend CanBoot. So now that the EBB is flashed, I remounted the print head to the printer, and then I had to deal with the issue of the wire loom. So in the past, the wire loom was supported by a wire mesh that went around it. Since this isn't the final form of my printer in its upgrade process, I didn't want to go ahead and add a wire mesh yet. So the first thing I did was use a zip tie to keep the CAN loom out of the way of the print head and any moving parts. And next, I used some spare 550 cord to basically tie the wire loom out of the way. Now, this is an issue I completely forgot about that I had to solve on the HeroMe 5. So I'd forgotten about this screw that you see. This was an issue in the HeroMe 5 cooling, and I had to use the original stock Vyper screw there because it's a lot shallower. It's countersunk and everything, so it can avoid hitting the cover of the X, whatever part of the X-axis this is. So what I ended up doing was just removing that cover, and that solved the issue. Maybe I'll design, or just, I don't know, I'll 3D print one that's slimmer or something in the future if I decide to. So after that, I remounted the BLTouch, and then I added the Gamma Master 0.4mm nozzle back to the Mosquito. So when I mentioned the 24 volts being a problem on the EBB42, Noctua doesn't make 24 volt fans. At least not in the form factor that I needed, the 4020 axial fans. And in my head, I was just thinking, okay, you can use pulse width modulation, do a 50% cycle to run effectively 12 volts average. I don't think the EBB42 does pulse width modulation. I might be wrong, but I had some spare L396s laying around. They're just buck converters. So I wired those up. I found a random place to mount them on the print head right next to the extruder. I ended up just adjusting the voltage down from 24 volts to 12 volts at first, and then off camera I ended up adjusting it down to 9 volts so that it would run almost perfectly silently, but still have enough airflow to cool the Mosquito. So after doing the basic configurations of the printer and clipper, just adjusting basically the configuration file, getting the extruder, the right step size, all that kind of stuff. I didn't really want to calibrate the printer, so I went ahead, I was too excited, I'd been spending weeks on this. I decided to go ahead and print a benchy. Now, for the printer not having been calibrated, this printed insanely well. I was surprised that it actually even worked. Of course, in order to be fair and get the most out of my new upgraded printer, I went ahead and went through the calibration process again. Now the calibration cube and the benchy both printed very well. They only have some minor issues like the Z-seam and a little bit of retraction. I think that comes from me not having any experience with a direct drive setup and just not being experienced with this new set of parts that I have. So I think over time that, it's going to improve. Now this took me by surprise. The Eiffel Tower printed worse with this new setup than it did with the V6. One of the issues that I think this comes from is the model itself I had to scale up, because in the slicer there were segments that were smaller than the nozzle could produce, the 0.4mm nozzle, so I had to scale it up. Unfortunately did not write down how much I scaled it the first time, but I think I didn't scale it as much the second time. Now I'm still planning to do upgrades like the motherboard, doing some maintenance on the V-slot wheels, a bunch of small things around the printer. So hopefully after that the Eiffel Tower will print near perfectly. So, what's the verdict? Were all these upgrades worth it? I think so. I'm really enjoying the lack of retraction issues that I've been plagued with on my stock Vyper. My part cooling fans are no longer clicking, which infuriated me. Now when I level the bed, there's not molten plastic left everywhere that the nozzle touches the bed. The print head is sturdier. The filament sensor is pretty convenient for loading and unloading filament. And all around, I think it just looks cool. Now, some of the downsides that I'm currently unhappy with are that I can't probe the entire bed because of the offset of the BLTouch to the nozzle. I'll try and fix that in future videos. I also don't like that the buck converter is exposed. I don't like how I'm currently spacing the gantry head with those 4 small, I assume, nylon spacers. It's just not enough surface area for me to think it's sturdy enough. I'm not really a fan of how I mounted the EBB42. It's a real tight squeeze. I can't adjust things easily if I need to or check things, and I would really prefer that. So maybe in the future I'll create a mount for that. Finally, the filament sensor needs a little work on its macros. It seems when I click the unload button, when I'm not heated up or when I'm heated up ends up having different effects. So I would really like to solve that. Well, this was an incredibly fun project. It's also my first real big kind of planned out, worked on YouTube video. I hope you enjoyed it. I hope you got some inspiration from it or learned something or just enjoyed watching it. In the future, I plan to make videos on all of these parts, doing reviews on them, updates on how I feel about the printer, and of course the next big upgrades to my printer, which will include changing the motherboard, upgrading the fans to make it more silent. I'll also be doing some upgrades to my resin printer that you can see right behind me over here. So whatever I end up doing next, I'd really appreciate it if you go ahead and check out my next video here. If you're interested in my content, want to stick around, subscribe, like, all the normal YouTube things. I've been Spencer, and thank you for tricking out my print head with me. See you next time.